Hello everyone, my name is Abhishek Pawar, roll number 171, and today we will be discussing about a Java project on the topic of conversion of number system. So let's get started. So let us have a look on the table of content. So in this we will discuss the mainly three types of conversion that are nothing but decimal to binary, decimal to octal, and at the end decimal to hexadecimal conversion. And we will also see the core explanation of all these three types of conversion. So let's get started with the very first type of conversion, that is nothing but decimal to binary conversion. Now, as we all familiar that decimal has a base of 10 and the binary number has a base of 2. So there are some steps involved for the conversion of decimal to binary number. So we have to assign the decimal number as a dividend. After assigning them as a dividend, we will divide that particular number by 2. Now why we are dividing it by 2? Because here the base is 2 of binary, so here 2 becomes the divisor. Now next is to store the remainder in the array. Now the remainder we are getting, we have to store into the array. Now in the case of 2, which is an even number, we will get the remainder as 0 or 1 because it is an even number. So whenever we divide an even number with any number, we get the remainder as 0 or 1. Now we have to repeat above two steps until unless we are getting a number that is greater than 0. Now we will print the array in the reverse order, which will be equivalent binary number of the given decimal number. So for our better understanding, let us solve an example. So we are given convert decimal number 112 into binary number. Since the given number is decimal integer number, so we are performing the algorithm of short division by 2 method with the remainder. So let us perform the division of 112 with 2. So when we're dividing it by 2, we are getting 56, which is an even number, so we are getting the remainder as 0. Let us further divide 56 by 2, and we are getting again an even number, which will assign 0 in the remainder side. Now we will again divide 28 by 2, again we are getting an even number, so we will assign 0 on the remainder side. Again for the next step, we are getting even number, so let us put 0 on the remainder side. But for the next three steps, you can observe that we are getting an odd number, so we will store 1 in the array because it is an odd number. So if we observed in the division method, whenever we are getting an even number at the end, we are storing 0 on the remainder side, and whenever we are getting odd number, we are storing 1 on the remainder side in the array. So as per the last step, we will write the remainder from bottom to up in the reverse order, which will be 3 times 1 and 4 times 0, which is equivalent binary number of the decimal integer 112. So that was all about how to convert a decimal number into a binary number. In the next, we will see how to convert a decimal number into an octal number. Thank you.
Before understanding the program, we will see how to convert decimal to octal. Convert from decimal to octal using the repeated division method used for decimal to binary conversion. Divide the decimal number by 8. We will see one example how to convert decimal to octal. In this example, 158 to the base 10 is equal to in this base to the 8, which is octal. In this case, we will need to convert decimal number to its equivalent octal number. In this number system, each type has its own base number, that is octal number, and his base number is 8. Similar as to decimal number has the base number of 10. To convert decimal to octal, we will need to divide by 8 and write the required remainder in the reverse direction. From the given example, 158 to the base 10 is equal to 236. We will write in the reverse direction to the base 8. Similar as to, we will see how to convert decimal to hexadecimal conversion. Before the converting the number from decimal to hexadecimal, first understand the meaning of decimal to hexadecimal. Uh, the base of decimal number system is 10, is also called as radix. Hence, it is a 10 symbol more precisely the number from 0 to 9. These include the 10 decimal digit, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and first six letter of English alphabet, which is A, B, C, D, E, F, are used to represent the value 10, 11, 12, 30, 40, and 50 respectively. We will see one example how to convert decimal to hexadecimal. From this example, 100 to the base 10 is equal to base to the hexadecimal to the base 16. Divide the number 16 repeatedly until the question will become 0. Well, 100 is the divided by 16. The question will be 6 and remainder is 4. When 6 is divided by 16, the quotient will be 0 and remainder is 6. We will write the remainder from bottom to top. So from the given example, 100 to the base 10 is equal to 64 to the base 16. Hence, it is how to convert decimal to hexadecimal, which is used in our code. Thank you.
So this is the Java program for conversion from decimal to binary number. So first I have import Java package, import java.util.star. Instead of that I can use import java.util.scanner, which imports scanner class. Then we created class convert decimal to binary. Class name is same as file name, which is pretended by public access modifier. In the class we created main method and the argument is passed as string array, public static void main, string args, square braces, and in the main method we declare num variable and initialize counter is equal to 0. Then we will create scanner class object and then print the message for user. Enter any integer number which stores those value into num variable. We also requires array integer binary value square braces is equal to new int size is 32 and the size of the array is 32. Then we use while loop where condition is num is greater than 0. In the while loop, num mod 2 means we divide num by 2 and stores its remainder into binary value of counter plus plus and stores value of num divided by 2 into num and end of while loop. Then print binary values stored in binary val. We will use for loop. We initialize I is equal to counter minus 1 and condition is I is greater than or equal to 0 and then decrement I and then print binary value for decimal number closing curly braces.
Hello everyone, myself Hitesh Suryavanshi, having roll number 173. To convert decimal to octal, we have to learn about both of the number system. First, a number with have base 8 is the octal number and the number with base 10 is the decimal number. Here we will convert a decimal number to an equivalent octal number. In decimal to binary, we will divide the number by 2. In decimal to hexadecimal, we divide the number by 16. In case of decimal to octal, we divide the number by 8 and write the remainders in the reverse order to get equivalent octal number. Decimal number, all the numbers to the base 10 are called decimal numbers. There are commonly used numbers which are 0 to 9. It has a both integer part and the decimal part. It's separated by a decimal point. Number of the left of the decimal are integers and the number on the right side, the decimal, is the decimal part. In octal number, there are the numbers with base 8. If the x is a number, then octal number is denoted as x is base to 8. It contains digits from 0 to 7. So, let's understand by code. So first, we will set class name as convert decimal to octal. After we will take a package Java until scanner and for to design an object for our scanner class which will help to take input from the user and we will set our object name. So next we will in this code we will first the code begins by declaring two variables like num and counter and it start by asking the user for an integer number and store it in num variable. Next, it's create an array of 32 integers called octal value and initialize them with 0. Then in while loop we used to convert the decimal number stored in number into 8-digit octal until there is a no more digit left num equals to 0. The code prints out all the values stored in octal value using system.out.print function. One of the from counter -1 to I is greater than equal to 0 where I is equal to 0 because there is no more digits left after converting number into 8-digit octals. The main method asks for input from user and store in it variable name num which will be used later on the converting decimal numbers into octal numbers into num. Store the input value for user scanner SC. So SC equals to new scanner system.in create scanner object system outprint enter any integer. Ask user for input num equals to sc.next integer. Store inputted value as its variable name as num. The code will be converted into input decimal number to octal value. Suppose let's run this code. Suppose we will put here value 32. We get is octal as 40.
So hello friends, my name is Yashudip Beldar and my roll number is 170. As in previous clips, my friends told you how to convert decimal to binary and decimal to octal with the help of Java code. And now we are moving towards how to convert decimal to hexadecimal with the help of Java code. So this is the code for to convert decimal to hexadecimal. So in this code, we are going to discuss how we can convert and how we have converted this decimal to hexadecimal. So let's start. So in the first line we have imported util package scanner class. Here we are using scanner class. So in the next line we have created one class called convert decimal to hexadecimal. So in this class we have made one main method. In main method we have initialized two integer variables called num and counter, where counter are defined as 0. In the next step we are creating object of scanner class which is sc. In the next line we are printing something which is enter an integer number, and in next line we have written number is equal to sc dot next int, which means we are taking integer input for the num. In the next line, to store maximum 32 digit of number, we have initialized one string called hex value, and also initialize one integer variable called digit to store digits. So in the next line, as we can see, we have implemented one while loop where whose condition is number greater than 0, which means the number must be greater than 0. If our number is 0 or less than 0, our loop will be terminated. And in the while loop we have written something code to execute when our condition is true, which is a digit equal to number mod 16, which means if we divide number by 16, the remainder of this process will be stored in digit. Okay, now in the next step we have taken switch case. We will discuss it later. So after we case if our output in the switch statement, if our output is 15, then our x value will be f, and if our output will 14, our x value will be e. We are doing this because we know in decimal to hexadecimal, when our 0 to 9 are same, but 10 to 15 are a, b, c up to f. Hence we have written these cases like that. If our case is 15, we will print f, 14 we will print e, 13 we will print d, 12 we will print c, 11 we will print b, and 10 we will print a. And in the default case we will convert our decimal number to hexadecimal with the help of predefined function, which is integer dot to string, which is a function to convert decimal to hexadecimal. And after we will divide our number by 16. After each of the iteration of this loop, our number will be divided by 16. Hence at the one stage our number will be less than 0 or 0. At that time our loop will be terminated and we will come outside the loop. After coming outside the loop, we have implemented one for loop to print that our hexadecimal value, where we have uses decreasing for loop to print that hexadecimal value, where we are printing hexadecimal value at character counter, where we have counter set as 0. Okay, so let's run it. If we will put, after running it, if we will put 12 1 2 3 4, we will get output as 4d2, which is hexadecimal form of 1 2 3 4. Let run it again. If we will write 4 2 6, we will get 2 3 4, which is hexadecimal number of 564. Thank you.